We have engineered our way onto the surface of the moon. We've even built machines that have successfully navigated beyond the outer edges of our solar system. Yet back here on Earth, across the entire 7,000-kilometer stretch of the world's largest river, the Amazon, humanity has failed to build a single bridge. It isn't for a lack of ambition. On the Godavari River in India, the scale of human effort to cage major waterways is immense. Millions of people and billions of dollars rely on gigantic barrages to control the monsoon surges. But recently, one of those billion-dollar structures cracked and dropped straight into the riverbed. We often assume concrete can tame nature. These mega rivers are showing us that our engineering has a hard physical limit. To understand why that limit exists, you have to look at the raw mechanics of the Amazon. Born high in the Andes Mountains, gravity pulls water down into a steep and vast basin that it forces 29,000 cubic meters of water into the ocean every single second. That volume creates a volatile landscape. In the dry season, the river averages 100 kilometers across, but when the monsoon hits, that width violently expands to over 150 kilometers. Any bridge built on dry land would be completely swallowed by floodwaters half the year. You can't bridge that gap by building longer spans, because the banks themselves are constantly moving. The soil here is largely marsh and incredibly soft. If you drive heavy steel and concrete pillars into this mud, they simply sink under their own weight. Add frequent regional earthquakes to the mix, and that already soft soil temporarily liquefies. The Amazon functions as a shifting geological system, one that physically rejects the rigid, static requirements of traditional bridge engineering. The Godavari River in India presents a different kind of defiance. It starts its journey a mere 80 kilometers from the Arabian Sea, on India's west coast. Gravity dictates a quick drop into that nearby ocean. Instead, the river turns its back on the coast and cuts 1,465 kilometers in the opposite direction, crossing the entire Indian peninsula to reach the Bay of Bengal. This strange route was carved 66 million years ago. Massive volcanic eruptions dumped a heavy layer of lava, physically tilting the tectonic plate eastward. The water now flows downhill through the rugged, mountainous valleys left behind by that ancient cataclysm. Modern engineers tried to harness this deep geological momentum by building the Medagata barrage, aiming to store and divert the immense water pressure. They underestimated the river's undercurrent. The ferocious flow of the water created an underwater vacuum. It silently sucked the sand straight out from underneath the concrete foundation, causing a primary pillar to collapse 1.25 meters into the riverbed. You cannot put a concrete lid on millions of years of geological force. Even when these massive dams manage to stay upright, the consequences downstream are devastating. Damming the Godavari has choked off the natural rush of fresh water that normally meets the sea. Without fresh water pushing outward, the Bay of Bengal's saltwater creeps backward, infiltrating the aquifers of the Krishna-Godavari Delta. This salt poisons the soil from underneath. A highly fertile agricultural hub is slowly calcifying into a barren wasteland. Over in the Amazon basin, we saw a similar chain reaction when engineers actually did manage to bridge a major tributary. In 2011, they built an 11,800-foot span over the Rio Negro. Almost immediately, this single point of access opened the forest to massive illegal logging operations, tearing into sections of the jungle that were previously unreachable. Each new road or bridge creates a puncture in the forest's armor, turning a remote ecosystem into an industrial zone. The unbridged stretches of the Amazon keep industrial-scale deforestation out of a jungle that produces 20% of the world's oxygen. On the Godavari, sinking concrete serves as a final physical warning. We preserve the planet's equilibrium by knowing when to let a river run its own course.